Okay, so hello everybody. This is Luboš Perklo from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a simulation workflow for all standard rotating machinery. The test case for today will be an axial fan. Just in case of any technical problems, feel free to contact us in the future and we will gladly answer all your questions or reminders. The webinar is going to take about up to 1 hour. In the first part, I will show you how to simulate an axial fan in Turbomachinery CFD. In the second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions to the comments. There's a chat window, perhaps on the left-hand side. You can put your questions. Just please do that. It's your time. I'm here for you. I will gladly answer all your questions later in this webinar. In the beginning, I'm gonna be quite general, but feel free to put your questions, and then I can go to the details. Perhaps I'm gonna show you my screen now. So okay, I'm sharing you my screen, so I believe you can see the same what I can see, and well. Yeah, now you can see the Turbomachinery CFD graphical interface. But before we come here, let me describe what is Turbomachinery CFD. So the Turbomachinery CFD is a unique software based on OpenFOAM. It was designed especially for CFD simulations of all rotating machinery, such as pumps, fans, compressors, turbines, water turbines, both radial and axial machines, both compressible and incompressible flows. Turbomachinery CFD is complete CFD workflow that covers all the steps necessary for doing those simulations, right? So it's comprehensive. Okay, so let me I will maybe I should show you. I will start from our website. So I'll say I'll search in the Google for Turbomachinery CFD, and where at the top you can see there's a Turbomachinery CFD from CFD support. Okay. Let me put just a quick review of. Okay, it's still loading, but I believe it's in a minute, in a second. Okay, so let me put just a quick review of its unique value proposal. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores. And that gives their investment in Turbomachinery CFD a permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the start to the final results can be run by a single command or a single click. The case setup is being done, the machine geometry is being read, all the process is being done really automatically. Simulation is done, the results are evaluated, and the final report is written down. So it's automated. Number three is Turbomachinery CFD is open source. That makes it easily customizable, and it's easy to modify it to your own purposes. And number four is the real tutorials are included, so the user has no doubts about the best practice settings. So there are real machines included that are already preset. So you can basically take them, replace the geometry, and modify the settings and run the simulation. So these are main benefits. Those were not all of them. I'm not gonna go for all of them, but these were the main ones. In case of any questions, just feel free to put your questions. We will describe them. We will tell everything. Okay. Okay. Yeah. Perhaps the most important information from today's webinar is that the most important information is all the information is available online. So you do not need to remember anything from this webinar. Everything is available online. I have pasted some major links in the chat window in the webinar, right? So you can click some links, or you have the information. Okay, so Turbomachinery CFD is available both for Linux and Windows operation system. The workflow is exactly the same. Turbomachinery CFD is very transparent. There is a trial version available for free for 1 month of period of time, so anybody can try Turbomachinery CFD, and afterwards he or she can decide to buy or not. So it's very transparent. You can download. You can click on CFD support web page. You can click download, and there you can click download software, and there you can choose your version either for Windows or for Linux, and you can easily provide your email, and you can click download, and you can download it. And what is important, you should follow the steps which are described in PDF, which is called start Turbomachinery CFD step by step. Again, it's available online, so you can follow steps described in this PDF, and you can run Turbomachinery CFD this afternoon. It's pretty simple. It's transparent, and we believe it's really easy to make it run. So you can download it here. Okay, and again, there are a couple of test cases. You can, again, in the download section, you can click download cases. There you will find Turbomachinery CFD tutorial cases. There are 7 tutorial cases. Axial fan, which will be object of this webinar. There's also a pump, radial fan, Francis turbine, and turbocharger turbine, compressor, and Kaplan turbine. So you can download any of these tutorials, and you can load them in Turbomachinery CFD, which brings me back to the Turbomachinery CFD, which is handled from ParaView. That's very important. So Turbomachinery CFD has its workflow. It's fully served from graphical interface, which is ParaView. Those are special plugins, special libraries for ParaView that create Turbomachinery CFD. And what is important, 100% of the workflow is handled from the ParaView, right? So all the settings, everything is handled from ParaView. In today's webinar, I will work from Windows system. The Linux is very the same, so it's the user's choice which operation system. Today I'm gonna work from Windows. Let's take a look at the Axial fan tutorial. Maybe I should show you a little bit. I'm going back to the website. There you can, in the references, you can find Axial Fan study. So there is described a little bit what's the case and how some background and some physics and a little bit of results. So the case study is available online, and yeah. So let's take a look at the Axial Fan. So the tutorial is available on our website. You can download it. Yeah. So the aim of each fan designer is, of course, the hunting the pressure ratios or the pressure, the flow rates, torques, and of course the efficiency, which is computed from these integral quantities. Each Turbomachinery CFD simulation has its inputs, and those inputs are the surface geometry, which is a 3D model that creates the machine we want to simulate, and also the settings, which is like physics, boundary conditions, speed of rotation, and constants and settings of the solver. And these settings, all these configuration settings are written in the configuration file. So I can show you how the case is represented on the disk. It's the yeah, you can see it here. So it's the couple of STL files, like the inlets, outlets, shrouds, hubs, blades, and the configuration file, which is a plain text file. Plain text file with all the settings inside. So you can either, it's possible, of course, to write all those settings manually, or do all the settings in the paraview. And again, you can save, load your settings, read new configurations, and play around this way. So there's the settings. You can simply open the configuration file and modify the settings according to your case, and the surface geometry, which is 3D data of your computational model. We can take a look. No, the surface geometry is .stl extension. It's STL format. It's typical for any CAD data. Yeah, this particular axial fan model was designed in software, in design software, which is called CF Turbo. CF Turbo is a special design software for a rotating machinery. I have it open. Actually, I don't. Okay, so I will open it. Okay, so there's CF Turbo. I'm going to open it. Anyway, CF Turbo is a special design software for a rotating machinery from German company CF Turbo, the same name as their main product, CF Turbo. Now I'm in CF Turbo, so I can open the Axial Fan example. That's the tutorial, Axial Fan. Okay, and yeah, so this is the meridian view. We can also take a look at the 3D model, and yeah, this is important. So basically the designer works in meridian. Here you can design all those hub and shroud and all the dimensions, or all the settings. You create the model here, and you design here, and what's important from CF Turbo, you can export to the Turbomachinery CFD. So you can export the case and the simulation settings, and you can read it directly in Turbomachinery CFD, and from here you can continue with the simulation. So the inputs to the Turbomachinery CFD, those are surface model, which is the 3D geometry of your machine. Today it's the Axial fan. So now you can see the Axial fan, the rotor blades, the white component, and the red component. Those are stator blades. And yeah. Okay, so this particular model was created in CF Turbo. It's again, go back. It's pretty strong tool, perhaps the best design tool for rotating machinery in the market available today. It's really smart, really easy to use, really interactive, really great tool. So I have exported to the Turbomachinery CFD. By the way, Turbomachinery CFD has its own data format, so you can, it's pretty simple. It's described in the, again, in the website. There you can in the page Turbomachinery CFD, you can click workflow example, and there you can learn what's the workflow, what are typical inputs, what are the outputs. So for the inputs, you can open a PDF document which we call Turbomachinery CFD configuration file manual, and there you can see what are the options, what are the keywords, and what are their values, and what are their dimensions, and what are the other options you can use. Okay, so this is the key how to write in Turbomachinery CFD format. So those are the inputs. Maybe I should, and the settings is the .tcfd file which is being read. So I have my Axial fan setup here. So I'm not gonna go for all the details. I can just briefly describe that there are some general settings, coordinate systems, of course the physics like viscosities, densities, reference pressure. What is important, you can specify number of speed lines, and each speed line may have its number of points. So you can, with Turbomachinery CFD, you can compute complete maps and complete characteristics of the machine, because you can specify number of speed lines, number of points, and then with a single click you can run the simulation and wait for the results. So speed line settings, of course the boundary conditions. Most of the machines are computed with the flow rate is prescribed, and pressure is fixed at the outlet. The same in this case with the Axial fan. There are some simulation settings, number of processors, limits on quantities, of course initial conditions, and then the geometry specification, number of components, the surface model is consisting from, and some mesh options. So yeah, that's the setup. So once I'm satisfied with my settings, case settings, I use a special filter of Turbomachinery CFD, which is called CFD Manager. So it's a filter, so you can find it in the filters, or you can click the icon with the colored arrows, and that's the CFD Manager. If you click it, you get a special menu where you can specify the name for your case where you want to simulate, and then you can write the case, and the OpenFOAM case is being run, being written down on your hard drive, and then you can click create the mesh, and the mesh process is done. Then you can run the calculation. You can handle the calculation by skipping to the next point or aborting calculation with or without writing your current results. What's important, anytime during the simulation, you can update the report. Report a special topic. I will speak about it in a minute. Very important thing is you can run all in one. So by clicking run all, you started the complete process. So automatically the mesh is created, simulation is done, and the results are evaluated. Which brings me to the report, which is a really important part of Turbomachinery CFD. So the point is any simulation which is done in Turbomachinery CFD has its report. The report shows all the integral results or many integral results of the simulation. What's important, you can update your report anytime during the simulation. So you can watch the most important results already during the simulation. That's really important. So there are some basic stats like statistics, how many cells has the mesh, what's, for example, what's the Y plus at every wall, for example, what was the time of the simulation, how many processors, what was the medium, what was the model. You can see the residuals, you can see how the flow rates developed, you can see what's the efficiency, and especially how it developed in time, or how it is standing against the flow rates. So we have 3 points and one speed line in this case in our settings. So there's one speed line for okay, there's some radians per second. Okay, and yeah, and that's the efficiency. The same for the torques. You can see how the torques or the torque on the acting on the rotor is developing in time, how it's standing against the flow rate. The same with a quantity which we call total pressure difference, which shows you how much of pressure is being created, and again how it developed in time and against the flow rate. Then you can see the total pressure per every interface. It's very important. You can see how your total pressure is being spent when flow is flowing through your axial fan, and again how it's developing in time at every interface. The same for the average velocity magnitude at every interface. You can also follow the circumferential angle and the meridional angle at every interface. That's
quite important. Yeah, so all these quantities are evaluated anytime during the simulation. That's important, and your report is stored for every simulation in HTML, so web browser format, so you can watch the results on any device. It's very comfortable for engineers to evaluate the results. Yeah, there is also of course the visual post-processing. So there's the integral values post-processing in the report. There is also special turbomachinery post-processing. The part of the Turbomachinery CFD, there is a special set of libraries for ParaView, which is called TurboBlade Post. It's part of Turbomachinery CFD, and it's a special set of libraries for ParaView, and they can post-process in a special way for Turbomachinery, and it can post-process the results of rotating machines. So I can show you, for example, one of the most important filters is called the meridional average, which can do the like circumferential averaging of all the quantities to a single meridian plane. So you can watch meridional plane, and you can see how your for example pressure is being distributed in circumferential average to this meridional plane. And another special filter is called turbo unwrap. It can transform your rounded rotational machine domain to the plane or to the box, and there you can easily make your planes in any level between hub and shroud over the height of the blade. So it's blade to blade view. Again, any quantity can be displayed. Okay, so this is just a very general, very brief description of Turbomachinery CFD, and I would like to know if there's a for a while I'll stop sharing my screen now. So it's back. I'm back. So thanks, and yeah, and I'm gonna take a look. I'm gonna take a look if there is some question. Okay, I can't see any question. Okay, and maybe what I can do is I can take a look. Okay, so yeah, so it's yeah. So there are no questions for now. So okay, so there are no questions. Okay, so I would like you to send me your questions. So you can send us anytime your questions or reminders to info@cfdsupport.com, or you can send it personally to me, lubos.pirkl@cfdsupport.com, and we are here for you. We are transparent. We want to describe everything. We want to tell you all the stuff. So feel free to put your questions, and yeah, okay. Okay, so I think there are no questions. So thank you for watching us today. Thank you for your time, and we will be in touch. So thanks. Bye.